P, Q and R are points of a circle with a centre K. So here we have a circle, centre K, with points P, Q and R on the edge. The length of the radius of the circle is 2 centimeters. So from K to Q is 2 centimeters. From K to R is 2 centimeters. The length of the minor arc PQ is 5 pi over 3 centimeters. So the length of the minor arc PQ is 5 pi over 3 centimeters. Part 1, find the length of the chord PQ. So find the distance from P to Q. Correct to 2 decimal places. Part 2, if PQ is equal to PR, so if PQ is equal to PR, then find the distance from Q to R. Find QR. Okay, so let's start with part 1. Find the length of the chord PQ. So I've drawn our circle out larger down here, and I've highlighted in yellow PQ, which is what we're trying to find. So we're going to let theta be the angle PKQ. So PKQ. So this angle here is going to be theta. Then L is going to be R times theta. So the length of the arc, the minor arc PQ, highlighted in blue, is going to be the radius times theta. And remember, the radius is 2 centimeters. We were told that in the question. So L, we were told in the question, which is the length of the minor arc, is 5 pi over 3. So we swap L for 5 pi over 3, and that's equal to 2 times theta, 2 being the radius. And now we just have to solve for theta. So to get theta on its own, we have to divide by what's stuck in front, which is 2. So it's going to be 5 pi over 3 divided by 2, which will give us 5 pi over 6. And we know that pi is equal to 180 degrees. So it's going to be 5 multiplied by 180 divided by 6, which gives us 150 degrees. So that angle at the centre there, theta, is actually 150 degrees. So now that we have our angle in degrees, we can substitute that into the cosine rule to find PQ. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos of a. So we're going to label up our triangle. So again, taking the triangle PQK, the angle is theta originally, but now it's going to be angle A, and it's capital A, and across from that is going to be lowercase a. So the length PQ is lowercase a, and then the other sides of the triangle highlighted in green are going to be the B and the C. It doesn't matter which way we label them. So we have B and we have C. Both of them are 2. So a squared becomes PQ squared, b squared becomes 2 squared, c squared is 2 squared, minus 2 times 2 times 2, and cos of a becomes cos of 150 degrees. Putting this into the calculator, we get 14.928, and square rooting it, we get 3.86 centimetres to 2 decimal places. So the distance from P to Q is 3.86 centimetres. So part 2, if PQ is equal to PR, find QR. So if PQ, highlighted in blue, is equal to PR, also highlighted in blue, then the angle PKR is going to be 5 pi over 6, because the triangle PKQ, so PKQ, and the triangle PKR, PKR, are congruent. So that means that they're identical. So remember, we got 5 pi over 6 in part 1. So if this angle here is 5 pi over 6, then this angle on the other side is also 5 pi over 6. Now if we want to figure out this angle here, we need to use the fact that all the angles around a point add up to 360 degrees, which is the same thing as 2 pi. So to figure out the angle QKR, which is this angle here, it's going to be 2 pi minus 5 pi over 6 minus 5 pi over 6, which leaves us with pi over 3. You can literally just put into the calculator 2 minus 5/6 minus 5/6, and you'll be left with a third, and then just stick the pi back in. So this angle here is pi over 3, or a third pi. Hence, as KQ is equal to KR, so KQ is equal to KR, because they're both radii of the circle, they're both 2. Then the angle KRQ, so KRQ, so this angle here, is equal to the angle KQR, KQR, this angle here, and it must be pi over 3. Because pi over 3 plus pi over 3 plus pi over 3 is equal to pi, and pi is equal to 180 degrees, and the angles in a triangle must add up to 180 degrees. So it's actually an equilateral triangle, and this distance here must also be 2. So the triangle KQR is equilateral, which means it has 3 equal sides, 3 equal angles, thus QR is 2 centimeters.